Hello, my name is Stefan Schwarzer. Welcome to this lesson about Keyline design. In this lesson you will get first insights into the Keyline design system, better understand the flow of water in the landscape after rainfall, and get to know different elements of Keyline design and its effects. Keyline design is a little bit of a complex design system. The central idea behind Keyline water management is to consciously slow, sink and spread rainwater by relieving compaction, opening up pore space in compacted soil and distributing excess water towards drier parts of the landscape. This has the effect of buffering the natural concentration of water towards valleys and reducing flooding. By maximizing the flow of water to the drier ridges, using precise plow lines or mounds that fall slightly off contour, we can infiltrate it across the broadest possible area. In this respect, Keyline strategies can be both a flood and drought mitigation strategy. Keyline water management has the potential to enhance the water efficiency of any production system. Keyline design was first developed in the late 1940s by Australian mining geologist and engineer P.A. Yeomans. He developed several farm properties with the goal of flood and drought proofing them. His focus was on accelerating the formation of topsoil by improving the soil penetration of oxygen, water and plant roots. There are a couple of books from him in which he describes his approach. The property you can see, P.A. Yeomans' Yobarni, was a very much eroded landscape when he bought it and implemented his system of check dams and contour line farming. Being in a dry area similar to Mediterranean conditions, he wanted to ensure that water from heavy rains can be gathered and can slowly infiltrate instead of leaving the property rapidly as surface runoff. Whether looking for land to purchase, for farming or planning the use of an existing property you own, the task of understanding and taking advantage of the unique environmental qualities your site has to offer can be daunting. As with any ecosystem, the ecology of a farm is complex and takes time to unravel. Taking the time upfront to properly understand your landscape means a greater likelihood of success down the line. Before discussing some practical tools for evaluating land, it's important to emphasize that in our experience, the most successful farmers spend time listening to the land. In other words, learning directly from it the limits and opportunities a given parcel has to offer. In most cases, it is far better to match a given enterprise or system to the land rather than try and work to shape the land to match the system. This is in fact the underlying concept behind the scale of permanence. The scale of permanence is a tool developed by farmer and engineer P.A. Yeomans in Australia in the 1950s as part of his strategy for farm use he called Keyline design. The scale was the backbone of this system for whole farm planning. The elements here are a newer adaptation from Yeomans' original version. The basic idea is that as one moves down the list, the elements of a farm system become less permanent. That is, they take less energy to change and are less permanent as a factor for planning as indicated by the graphic. Looking at the list, we can note that the factors of landform and water, while potentially changeable on the farmscape, would require large machines moving earth around, while the simple planting of a bed of flowers or the removal of old farm debris could dramatically improve the aesthetics and experience of a site. In the same sense, building a proper pond would be a change that would last hopefully at least several hundred years, while a well-installed livestock fence or buildings or infrastructure would be impressive if it reached the 100-year mark. The exact order of the list can be variable depending on the site and situation. One item on the list might come as a surprise to some. Number 10, or soil, is far down on the list, which implies that it is relatively easy to change. While it is true that largely the structure and parent material of the soil are certainly permanent and nearly impossible to change, having in some cases formed over thousands of years, as farmers we know that one of the quickest items we can affect is the health and the vitality of our topsoil, or the top 10 to 30 centimeters. Through rotational grazing, amendments, cover cropping, aeration, etc., the change in productivity and organic matter can in fact change rapidly. Another brain twister is number 4, which is called invisible structures, meaning the unseen forces that affect the landscape. We can call this social and economic factors that affect the farm, which can be anything from your personal finances to the influences of neighbors or the zoning or legal limitations of your municipality. This again might be higher or lower on your personal list depending on where you live and what your specific situation is. What we see on this illustration is a piece of a map with, in black, the contour lines. Highlighted in straight lines are the ridges within the landscape in red and the valleys in blue. This map shows the natural flow of water on the surface as well as in the soil. Water always wants to go straight with the slope, the fastest way possible. Thus, normally in a 90-degree angle to the contour lines, and thus flows away from the ridges to the valleys. The central idea behind Keyline design from a water perspective is to capture water at the highest possible elevation and distribute it outward toward the drier ridges using gravity, slowing the natural concentration of water in valleys. Maximizing the flow of water to the drier ridges using precise plow lines or mounds, falling slightly off contour slows the movement of water and spreads it more uniformly, infiltrating it across the broadest possible area. It is, as said before, both a flood and drought mitigation strategy. With the threat of extended flooding and drought predicted with climate change, it is becoming even more important to better manage abundant winter rainfall for times of scarcity. On the right image, we can see the central key line, which starts in both directions at the key point, which is the location where the lower and flatter portion of a primary valley floor suddenly steepens. The lines in parallel to that contour line are the direction and path of cultivation. Notice that only the key line is purely on contour. The other parallel lines encourage water to shed towards the ridges. This is essence of keyline cultivation, allowing farmers to cultivate in parallel rows, something nearly all farmers do, while optimizing both drainage and water retention. The tool most often used for putting these structures into place is the Yeoman's Keyline plow, which enables subsoil ripping using keyline geometry. It penetrates the subsoil, trying to go a few centimeters below existing rooting depth without inverting the soil. The effect is to loosen compacted soil and open up micro water harvesting and diversion ditches across the landscape. In some pastures, it is possible to increase the rooting depth of forage plants by breaking up hardpan and allowing root access into these microfurrows. With water and root activity deeper than before the treatment, the opportunity exists to create carbon storage deeper into the profile via root exudates and soil microorganisms. This illustration shows the idealized soil formation on compacted pasture, highlighting how the Keyline plow goes at each pass, once or twice a year, below the existing roots to lose the soil and enable the plants to conquer these newly created highways into the depth of the soil and enrich these deeper horizons with their root exudates and the adjoining soil life, creating rich humus in deeper layers of the soil, with more water infiltration and retention capacities and other valuable effects. On the right image, we see how the pasture looks like after the plow did his work, only cutting into the earth and lifting a little bit the ground from below in order to break up the compacted soil layers. Another important facet of Keyline design is the establishment of effective water storage ponds on the landscape. With this, winter rainfalls can be stored for summer times, and when heavy rainfalls happen, the water can be first stored on the property where it can infiltrate slowly into the ground, filling the groundwater and feeding springs. Another often used element within the Keyline design system are swales. These are ditches almost put on contour, that is, with a very small slope, which collect runoff water, thus reducing soil erosion, but especially keeping the water on the terrain. This is especially important for areas like the Mediterranean, but steadily in countries like Germany as well due to climate change, where heavy spring or summer rains can occur, which on agriculture fields often run off and disappear. But we must try to keep that water on the fields so that it can slowly soak into the ground, feeding the soil and thus the plants and the groundwater reservoirs. Often, Keyline is associated with the establishment of tree rows, agroforestry, and or swales. The permanent grass stripes help to further reduce soil erosion and keep water on the terrain. Here's an example from Australia, Neverland, where the founder of Keyline Design, P.A. Yeomans, has made a completely degraded area fertile again. In the picture we can see how the almost contour parallel water retention leads to the fact that downhill wonderful green areas can be seen on the pasture, as the water can now slowly seep away, diffuse into these areas and supply the vegetation there. Here's a view on how Mark Shepard, famous permaculture farmer, integrated Keyline design into his farms. The arrows show the direction of the water flow from the valleys to the ridges. And in between and parallel to the tree rows are annual or perennial cash crops, which allow for efficient machine harvesting. Thank you for watching this lesson.